Hello viewers, welcome again to today's lesson. This is the Solution Space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want us to continue with the logarithm that I started with you in the previous videos. In the previous videos, we started learning about logarithm, where we started from the basis and we looked at the definition of logarithm, where we've done a detailed explanation on it, and also we used some basic examples to establish the definition of logarithm. Then we went ahead and looked at how to convert some basic log equations into exponential form, and that simply means that you have log equations and you are being asked to write it in a form that there's no more log inside it. That we've explained into detail, and also we've solved some examples on it as well. Then we went ahead to also look at a situation where you have exponential equations and you are being asked to convert it into logarithmic form, and that also we've explained it into details. What that means is that you are just supposed to write the given exponential equation in a form where you are going to introduce log into it. That we've done many examples on it all in the previous videos, and I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to proceed and look at the laws of logarithm. So that's what I want to teach you in this video. And the laws of logarithm is a very important aspect of logarithm. Everything that you are going to look on from here is built on the laws of logarithm. So it's very important that you pay a very close attention to it so that you can understand it. And also, we are going to apply the knowledge that we've gotten in the previous videos on the logarithm. So I will encourage you that in case you don't have any idea of what logarithm is, you have to go and watch the previous videos to lay the foundation, because you are going to apply the knowledge from those videos to establish the laws of logarithm that you are going to look at in this video. And please don't forget to also like the videos and also share them after watching. And if you are watching for the first time, please do want to follow my page and also subscribe to my YouTube channel as well. So as I said, in this video, we are going to look at laws of logarithm. Okay, we are going to establish some laws of logarithm that will help us to be able to solve some questions. And before I proceed and look at the laws of logarithm, there's something very important and also vital in establishing the laws of logarithm, and that is we looking at some basic properties of logarithm. So before we come and tackle the laws of logarithm, I'm going to start with some basic properties of logarithm that you are supposed to know, because it's the knowledge of those properties that will help us to be able to establish the laws of logarithm. Okay, so now let's start with the properties. Now, the first property of logarithm that you are supposed to take note is that the log of any number to the base of that same number is always equal to 1. I'm going to reiterate it one more time. I'm saying that the first property that you are supposed to take note in logarithm is that the log of any number to the base of that same number is always equal to 1. Let me write it on the board for you to understand better. Okay, so now think of any number. Okay, you can think of any number. Let's say 2. Let me use 2 here as an example. So the property says that the log of any number to the base of that same number is always equal to 1. So we are using 2 as an example. So now, if I have 2 on the board, the definition is saying that the log of the 2, so the log of the 2 to the base of that same number. So I'm going to have 2 here as a base. It should be equal to 1. So that is the meaning of the definition that I just read to you. Okay, so the log of any number to the base of that same number is always equal to 1. So look at it. I have the log of 2 to the base of that same number. Have you seen it? So the same 2, we have it as a base. So the log of any number to the base of that same number is always equal to 1. So when I have, let's say I have 3. So when I take the log of 3 to the base of the same 3, it should be equal to 1. So that's the property. So again, let's say I have the log of 10 to the base of 10, it should be equal to 1. I hope the explanation is clear enough up to this point. So one more time, the log of any number to the base of that same number is always 1. So in general, we can say that if I have log a to the base a, it should be equal to 1. If I have log s to the base s, it should be equal to 1. If I have log y to the base y, it should be equal to 1. Okay, so that is the definition, and I hope you understand. So now we are going to look at the next property. Okay, so now let me clean this from here so that we can go ahead and look at the next property. And please keep these properties in mind because we are going to apply it to establish the laws of logarithm. So keep this in mind. So let me go ahead and look at another property which is very important. Okay. Okay, so now the next property that I want us to look at is that the log of 1, I mean the number 1, so the log of 1 to any base is always 0. One more time, the log of the number 1 to any base is always equal to 0. Let me write it on the board. So the log of 1 to any base, let's say I have to the base 3, it should be always equal to 0. I hope you understand. So think of any other base that you can consider. Okay, so let's say the log of 1 to the base 10 is always equal to 0. Let's say the log of 1 to the base 5 is always equal to 0. So that is the meaning of that property. So the log of 1 to any base is always equal to 0. And I hope you understand up to this point. So these are the two basic properties you are supposed to know. But let me introduce one more property which is very important because you are going to use it in establishing the laws of logarithm. Okay, so let me introduce that property to you. So let me clean this from here. I hope you understand this. Please keep it in mind because we are going to use it to establish the laws of logarithm. Okay, so I'm going to clean this so that we look at the next property which is very important as well. So now the next property says that if I have the log of, let's say, s to the power n. Now I have log s to the power n. Now someone is wondering, I didn't bring any base there. Very important. Now if there's no specified base, it means that the base is always 10. Okay, so let's say I write log 3 to the base 2. Have you seen with this one? I've specified the base. The base is 2. So log 3 to the base 2. But in case I write only log 3 there without any specified base, it means that the base is always 10. So immediately you see that the base is not written, it means that the base is 10. You have to keep that in mind. It's just like me writing 2s on the board and also s here. Now, if I ask you what is the coefficient of this s, you can easily tell me the coefficient is 2. If I ask you what is the coefficient of this s, you can also tell me, and which is 1. Because we know that when there's no specified number in front of the variable, it means the coefficient is always 1. I hope you understand. So it's the same thing. So when I write the log and I don't specify the base, it means that the base is always 10. So you have to keep that in mind. So this log s to the power n, it means that the base here is what? 10. I hope you understand. Okay, it's just like me also saying that, asking you that what is the power of this s. The power of this s is 1, because you know that when there's no specified number, it means the power is also 1. So it's the same thing that we are applying to this one. So when there's no specified base, it means that the base is always 10. Okay, so that's what we have on the board. So keep this in mind. Okay, so if I'm to ask you what is the base of this log that I've written on the board, the base is what? 10. You are supposed to know, because I've explained that if there's no specified base, it means that the base is always 10. Okay, now I want to proceed with the next property, which is very important. So assuming I have log s to the base, log s to the power n. Now, the law of logarithm says that the power that we have here, which is the n, it can come in front of the log. Okay, it will come and become a coefficient of the log that I have here. So we are going to have it also written as n log s. So that is the next property. I hope you understand. I'm going to go over one more time. So let's say I have log a to the power b. Now, the property is saying that having log a to the power b, the b here can come and become a coefficient to the log. Okay, so it will come in front of the log. So I can write it as b log a. That's all that we are saying. I want to establish. I hope you understand. So if I have log s to the power y, I can also write it as y log s. I hope you understand. So this is the next property, which is very important, that we are going to apply in establishing the laws of logarithm. So please keep these 3 properties that I've taught you in mind. We are going to apply it. Okay, so let me clean this one and let's proceed and start to establish the laws of logarithm. Okay, so now we are going to start with the first law of logarithm, which is the product rule, okay, or product law. Okay, so that's what we are going to start with. We are going to derive that law. Okay, so now suppose, so let me write, first of all, let me write the product rule or law. Now, okay, we are going to suppose something to be able to establish the product rule or law of logarithm. So now, let's say, suppose the log of s to the base a equals to n, and log y to the base a equals to n. We want to establish the product rule of logarithm. Okay, so we are just supposing this. So having log s to the base a equals to n and log y to the base a equals to m, we are going to use it to establish the product rule. Okay, product means multiplication. Okay, so now let me take the first equation. So the first equation, I have that the log of s to the base a equals to n, and I've taught you in the previous videos how to write a given log equation in an exponent form, meaning that you are going to write it in a way that it does not contain any more log. So we are going to apply that here. Very important. That's why I keep on encouraging you to do or to watch the previous videos, because all this I've established it in the previous videos. We learned how to convert some basic log equations into exponent form, meaning that you are going to write those equations in a form that it does not contain any more log, and that's what you are going to apply to this one. Okay, and now to do that, we are going to maintain our s here, bring our equal sign, and this a will come and carry the n as a power, so we are going to have a to the power n. I hope you remember this. We've done in the previous videos. Let me go over one more time. I have log s to the base a equals to n, and I want to write it in a form that it does not contain any more log. Okay, so how do we do that? Just maintain your s, which is here, and the base, which is the a, will come and carry the n here as a power. So we are going to have s equals to a to the power n, and that's what I've written here. So if I have something like this, let's say I have log a to the power, let's say log a to the base s, okay, equals to y. I want to use this one to explain it further to you to be able to understand this. So I have log a to the base s equals to y. I want to write it in a form that it does not contain any more log. Okay, so how do I do that? I'm going to maintain my a here, bring my equal sign, and this base, which is the s, will come and carry the y as a power. So I'm going to have s to the power y, as simple as that. So that's how to convert basic log equation into exponent form, in a form which it does not contain any more log. So that's what we just apply to this one. Okay, so let me clean this one and let's proceed. Okay, so now from the first equation, we've been able to establish this, that s equals a to the power n. So I'm going to label this one as equation 1. I hope you understand and you agree with me up to this point. Now we are going to pick the next equation, okay, which is the log y to the base a equals to n. That one we are going to write it in a form that it does not contain any more log. So I have, let me write it, I have log y to the base a equals to n. So writing it in a form that there's no more log inside, all that you have to do is that when you maintain your y, which is here, bring your equal sign, and this base a will come and carry the n as a power. So you're going to have a to the power n. So we have y equals to a to the power n, and that is it. I hope you understand. So we are going to label this one as our equation 2. So we have this to be our equation 2. Now, because we are looking at the product rule, product means multiplication. So we are going to multiply equation 1 and 2. Are you okay with it? So let's do that. So we want to look at equation 1. Equation 1 times equation 2. Okay, so if I pick equation 1, I have s equals a to the power n. And if I pick equation 2, I have y equals a to the power m. So we want to multiply them. So it's going to be s times y. Okay, so we are multiplying. So s times y should be equal to the a to the power n times a to the power m. So a to the power n times a to the power n. I hope you understand and you agree with me up to this point. I'm going to go over one more time. All that you are doing is that now that we've gotten equation 1 and 2, we want to multiply them because we want to establish the product rule or the product law of logarithm. So now equation 1 is given to be this, equation 2 is given to be this. Now we want to multiply them, so it's going to be s times y. So s times y, I've written it there. Bring your equal sign, then we have a to the power n times a to the power m. That's what I've written here. I hope you understand up to this point. Let's proceed and simplify. So s times y is going to give sy. So let me write my sy equals, then I have a to the power n times a to the power m. Now we are going to apply the indices that we know. You know that from indices, we know that when the bases are the same and they are multiplying, we add powers. So we are going to apply that here. And I've already taught you indices as a full topic in previous videos. Okay, so just search for those videos on Facebook or YouTube. Okay, the solution space, you get it and you'll be able to easily understand. So we are just applying that indices law that if the bases are the same and they are multiplying, we add powers. So I'm going to have a to the power n plus n. Okay, as simple as that. You pick one of the base and you just simply add the powers. Are you okay? So I have sy equals to a to the power n plus n. Okay, now from here we are going to introduce log. Okay, so how do we introduce log into this equation? All that we are supposed to do is to take log of both sides. Are you okay? Anything you do to the left hand side, you have to do the same thing to the right hand side also. So from here we need to take log of both sides to introduce our log. Okay, so now I'm going to have the log of sy to the base a. Now if someone is wondering why to the base a, it's because from the premise we say suppose log s to the base a. So if you have introduced log into 8, it means it have to be to the base a. Okay, so we just want to take the log of both sides. So the sy, I'll take the log of it, and this a to the power n plus m, also I'll take the log of it. So the log of sy to the base a should be equal to, then the right hand side also I take the log of it. So I'm going to be the log of a to the power n plus m to the base a. I hope you understand and you agree with me up to this point. Okay, so now we are just going to go further and do some basic simplification. Okay, now I'm going to maintain my log sy to the base a here. It should be equal to, now don't forget, I taught you a property right in this video that when you have something like this, let me remind you of it. If I have log, let's say s to the power n, it can be written as n log s. Why? I explained that the power will simply come and become a coefficient to the log. Okay, so having this, it can also be written as this. So look at this. We have n to the power n plus m here. okay, which is a power to the a. So we are going to apply that. I hope you get it. We have log a to the power n plus m to the base a. So we are going to apply this property to that to write it in this form. I hope you can do that. So let's go ahead and do that. So let me clean this one and let's proceed. So the power that I have here, which is the n plus m, will come and become a coefficient to the log here. So I'm going to write it as the n plus m, okay, multiplying log a to the base a. That's the property that we just linked. I hope you are okay with it. So the power here will just come in front of the log to become a coefficient to it, as simple as that. I hope you're okay with it. Now, let's proceed from here. Take note that I taught you another property right in this video, that the log of any number to the base of that same number is always 1. Don't forget. So if I have log, let's say s to the base s, it should be equal to what? 1. If I have log 10 to the base 10, it should be equal to what? 1. That we've established that. So we are going to apply that here because we have log a to the base a here, which means it's going to be 1. So let me clean this one and let's proceed. Okay, so I'm going to have log sy to the base a. Let me write the a word. To the base a should be equal to my n plus m multiplying log a to the base a. And you know log a to the base a is supposed to be what? 1. So in place of log a to the base a, I write my 1 there. I hope you understand. So let's go ahead and simplify further. So I have log sy to the base a equals 1 multiplying this one. It's like you are doing removing of bracket. So 1 multiplying this one, you are still going to have n plus m. I hope the explanation is clear enough up to this point. Okay, so now from here, let's go back to the premise of establishing the log. What did we say? We said that we are supposed to suppose log s to the base a equals to n and log y to the base a equals to m. Now, in place of the n and the m, we are going to do a substitution. Okay, because we know that n equals to log s to the base a. So in place of n, we are going to put this whole thing there. And I hope you understand. Let me go over one more time. All that we want to do from here is that we want to do a substitution of the value of the m and the n. Now, n equals log s to the base a. So in place of n, we are going to write the log s to the base a there. And m equals log y to the base a. So in place of the m, we are going to put that one there. As simple as that. That's what I want us to do. So I'm going to repeat my log of sy to the base a equals the n, its value is log s to the base a. Bring your addition sign plus the m, its value is log y to the base a. As simple as that. We just introduce our values for n and m. So now we are having this one. So log sy, what are you seeing? Look at it. S and y, they are multiplying. So that's the product rule. So log sy to the base a equals the log of s to the base a plus the log of y to the base a. And this is the product rule or the product law of logarithm. So which is this whole thing that is written here. Okay, so that is the first law of logarithm, which is the product law or the product rule. I hope the explanation is clear enough up to this point. So it means that when you have log sy, which is a multiplication between s and y, log sy to the base a, it can be written as this. it can be written as the log s to the base a plus log y to the base a. As simple as that. Okay, so the log here affects the s, so you write it. So log s to the base a, that's what is here. And the log here affects the y, so log y to the base a. Then you bring your addition sign. As simple as that. I hope the explanation is clear enough up to this point. So before I end this session, let's do some basic explanation on this before I end this session. Okay, so let's say I have let me write it here. Let's say I have log a to let me make it log ab to the base s. Okay, so from the log that we've established, this can be written as the log of a to the base s. So the log will affect the a, then you bring your base s, then bring your addition sign, then this same log will affect the b. So log b to that same base, which is base s. As simple as that. So that is the product rule that we've established here. I hope the explanation was clear enough and you understood it as well. We are going to use this law to solve questions. Okay, that's why it's necessary that I establish the law, so that when we begin to apply them in solving questions, you'll be able to appreciate it and understand. Thank you, and please don't forget, like the video for me and also share the video. And if you are watching for the first time, please follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we look at the second law of logarithm. Bye bye.